Goldsmith law, right? Goldsmith law. And if you remember both the laws, basically it is the radius of the cation divided by radius of the anion. That will give you a certain rating index, and that will be the index for the coordination number. And this number is what? This number is for a satisfying one particular central cation, how many anions is required. Okay? So this coordination number is the basis of crystal structure. Like if we are taking silica and oxygen is the surrounding anion, then it will be, the coordination number will be 4. So the crystal structure will be tetrahedral. Likewise, if it is aluminum, then aluminum with the surrounding anion, the rating will be for 6. That is the octet, right? So that was the first law, and then the second was the isomorphous substitution to the tune of 10 to 15% is admissible, right? So any particular central cation can be isomorphously replaced by other cation. Isomorphous means similar size. Okay? So 10 to 15% if the difference is there, that is admissible. Like silica may be substituted by alumina may be substituted by magnesium, iron, like that. Okay? And then because it is in the universe, the content of silica, oxygen and aluminum was very high. Together these three was constituted almost 85%. So mostly the soil formation process is the sharing of silica and oxygen. And that triggered silica tetrahedral, that is starting from SiO4, that is SiO4, this was the silica tetrahedral structure, SiO4 where the sharing was 1:4. Similarly, we reduced to 1:2, silica and oxygen share. And in between, we could see it was all starting from nesosilicate to solosilicate to cyclosilicate to inosilicates of single chain structure and double chain structure, and then it was phyllosilicates, and then it was tetrosilicates. And out of this, I said phyllosilicate is the principal component which regulates the characteristics of a soil. Okay, and this part we discuss with the structure and the basic unit and what is the charge distribution. That part also we cover. And thereafter we switch over to what is called a silica tetrahedron, and then what is called a silica tetrahedral layer. That we discuss. And there I said it is 1, 2 gap, 1, 2 gap, 1, 2 like that. Or you can see 1 gap, 2, 1 gap, 2 like that. Whatever you want to say. Or gap 1, 2. So the orientation is 2 consecutive molecules of silica will be sharing, and then one silica molecule will drop once again 2 consecutive molecules. That will be the silica tetrahedral shape along A dimension as well as B dimension. Okay, so in A, B and C, if you consider this in 3 dimension, so in 2 dimension it will be like that. So after this part we discuss. Similarly, I said it is because of oxygen, silica, aluminum, then calcium, iron. These are the components, main component, and they are contributing almost 90% 5 of this, more than 90% of the total content. So this will be, the first reaction is this, now second reaction will be this. And once again, if you see, from the radius, cationic radius divided by the anionic radius, in case of aluminum, we could find the coordination number is 6. So alumina will be the octahedron. And so one central aluminum ion will be surrounded by 6. Okay, so this is aluminum, this is either oxygen or hydroxyl. This is either oxygen or hydroxyl. And another thumb rule I said, remember, always in silica tetrahedral, silica will be linked with oxygen only, right? And in case of alumina, it could be either oxygen or it could be hydroxyl. Up to this we discussed, right? Fine. So, now once again, the silica tetrahedral layer, I just repeat so that you can do along with me, try to follow. 1, 2, then gap, 1, 2, once again gap, 1, 2, it will go on like this. So this is the smallest unit, right? And remember, always, this you have to consider as a 6-layer molecules. How? Because alumina will be 6. Considering that the smallest unit will be sharing the 6 molecules, either of oxygen or hydroxyl. Okay? So once again, another tips. So remember, I said once again, this oxygen, oxygen, in between there is one more oxygen, 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 and one more of the next, because this is a continuous chain in the A and B dimension. So this is the silica tetrahedral layer, or this. Okay? Now this also will be shared. Now this will be sharing over there, there. So this is another 6. Now this followed this. So this is the smallest unit of silica tetrahedral layer. Am I clear? So I said 1, 2 gap, 1, 2 gap, 1, 2. It is a continuous process. So the smallest unit 1, 2 gap, 1, 2. And I said this silica is sharing with the oxygen. So this is the orientation. Remember, 6 molecule, 4 molecule, 6 molecule. Now, this alumina, it is, now the charge of aluminum, the charge of aluminum is +3, +3. So if it is hydroxyl, it will be -6. If it is oxygen, it will be -2. So depending on oxygen or hydroxyl, the sharing will be varying. Okay. Now once again, what type of sharing alumina will be doing? Based on that, we call this could be the silica tetrahedral sheet is only one type, but alumina octahedral layer could be of 2 types. Okay. One is called dioctahedral structure, and another is called trioctahedral. One is called dioctahedral, another is called trioctahedral. Now what is dioctahedral? Dioctahedral means alumina is having 3 charge. Di means out of 3, if 2 part is filled, that means when two-third of the entire charge is filled, we call dioctahedral. Okay? And that means, once again, if it is out of 3 aluminum molecules, take it that way, out of 3 aluminum molecules, if 2 is present, that kind of orientation will be in case of dioctahedral. In a larger scale, like it is a continuous one. So I said when the 2/3 of the charge of the aluminum will will be satisfied or will be filled, that will be called as dioctahedral structure. And so, how it will happen? So, out of 3, 2 should be there, right? So, if it is a continuous chain, so aluminum orientation, it will be like out of 3, 2. Okay? I am coming to details of it also once again. Now, what is tri? When all the charge field, that means 3, 3. 3 by 3. Just a 1, 2 gap, 1, 2 like silica I said. In case of alumina, dioctahedral, once again, remember, if it is 1, 2 gap, 1, 2, now remember, if you are constructing any building, if consecutive 2 bricks are there and then 1 gap, so over the gap, you need to have 1 beam, right? So, this is what, this is a continuous, like this you understand, this is A dimension, similarly, length and breadth will be the B dimension, but the height dimension will be sharing with alumina octahedral. Height dimension will be sharing with the alumina octahedral. If it is 1:1, that means 1 layer of silica with 1 layer of alumina octahedral. Further, if it is 2:1, 1 layer silica, 1 layer alumina octahedral, here 1 layer of silica. Just like burger, you take in between. Okay? So, aluminum is in between, whether it is the macalu or the chicken, whatever it is. So, this is in the C axis. What is in the A axis? Just